get started on this parabola over here that we've got going, right? If x is equal to 1, guys, if I replace x with 1 here, I'm going to get 2 multiplied by 1 all squared minus 1, which is equal to 1. So when x is equal to 1, y is equal to 1. Hi, Joe. Okay, when x is equal to 0, y is equal to -1. And when x is equal to -1, y is equal to 1 again. All right, if we sketch this on our graph, that is x is equal to 1 over there, y is equal to 1 over there, x is equal to -1 over here, y is equal to -1 over here. At x is equal to 1, y is equal to 1, x is equal to -1, y is equal to 1, and x is equal to 0, y is equal to -1. All right, so this should be where my graph is. It should look like that. Hi, Tyra. So tell us what's happened. What has happened? Let us know. Let us know. Okay, so this is the graph that you should have, and this is the graph you should be able to draw by now, because we've done parabolas in the lesson that we had before. All right. So today we're going to be continuing quadratic functions, but we're also going to jump into hyperbolic functions. The first thing we're going to be learning about today, guys, is what to call things when they're given to us in a certain context. All right, so I'm going to take my Cartesian plane over here, guys, and I just want to add one thing over here. I'm going to do that, -2. I want to add a -2 there. All right, so if I had to sketch the graph of x squared minus 2, y is equal to x squared minus 2, I would end up with a graph that looked like that. All right, like that. Okay, and again, don't judge my drawing. Okay, don't judge my drawing. I know you guys, I can already hear people telling me I'm drawing dogs when I'm drawing bicycles. I'm watching you. Okay, now if we want to look at our turning point, guys, our turning point is this point over here, where when my y values for my graph were going down, they were going negative. They start over here and they become 0. And then all of a sudden, my y values start going up. They start to become positive. So they're going towards the positive side. This point right over here is called our turning point. Okay, it's called the turning point. All right, now the turning point tells us exactly where our graph ends. Like we can't get any values underneath the turning point. Okay, so if the turning point over here is -2, if I try to find an answer for -3, my calculator is not going to give me an answer, because at -3, I don't have any part of my graph at -3. Okay, so my turning point is that point where my graph starts going from negative back up towards positive. All right, my x-intercepts, guys. Remember we were learning about the x-intercept, and you said if we want to find the x-intercept, we need to make y equal to 0. So whenever we look for an x-intercept, we're going to make y equal to 0. And what the x-intercept is going to do is it's going to give us these 2 points here. It's going to give us the points where our graph cuts the x-axis, these points here. And coincidentally, the reason why we make our y equal to 0 is because our y values over here will be 0. We don't know what our x values will be, but our y values will definitely be 0 and 0. Okay, what about the y-intercept? Tell me in the chat, guys. If I want to find the y-intercept, what do I need to do? For the y-intercept, what do I need to make? X needs to be equal to what? No worries, Alicia, welcome. Good, we're going to make x 0. Good, x is going to be equal to 0, 100%. And funny enough, when we make x 0, it's going to give us our turning point. Y is going to give us our turning point over here. Not all the time, only in grade 10, because when we get to grade 11, our turning point is going to shift. So at the moment in grade 10, our turning point is going to be our y-intercept. No way. Alicia, we've already started. Don't even. A whole celebrity that we've got here. Okay, technically we were still doing a recap. Technically, we were still doing a recap. So you didn't miss anything, actually. You came right in time. Okay. Nice what teacher knows. All right. So guys, the domain, when we talk about the domain, guys, we want to look at what our x values can be. Now, if I had to ask you guys over here, if I had to put y is equal to x squared, can anybody find me a value for x that is a real number that x cannot be? Which number can x not be equal to? Any real number? Well, Naman, if it's equal to 0, I'm just going to get that y is equal to 0 squared, which is equal to 0. 0 is a number. So 0, no, 0 doesn't count. Is there any number that I can put into x that won't give me an answer for y? Any number. Think about it, guys. -1, up here it says -1, y is equal to -1, all squared is equal to 1. It gives me an answer. Namani says 1 is equal to y squared, which is equal to 1. That's also an answer. Any other number that we can think of that's not going to give us an answer? Infinity, y is equal to infinity squared, which is equal to infinity. Yes, Queen Jasmine, sorry, I keep calling you Queen Jasmine. I must just go with it. I must just go with it. Yes, Jasmine.
0.
Well, if I put 0 in, I'm going to get y is equal to 0 squared, and that's going to give me 0. That still gives me an answer. Can you think of any other number? 0 is still a number.
No, I don't know. Today I don't know.
No. 121, Lesedi. There's no number. I'm going to tell you, Jasmine. There's no number that x cannot be. So what we can do here, guys, is for our domain, we can say that x, no, maths error is not the answer. Okay, x can be any number. X is any number. So what we can say, guys, is x can be any number that is a real number. Now, because I'm realizing my issues, when we say XER, what this is actually saying, no worries, no Mahlubi, welcome. What this is actually saying is that X is an element of, and this R stands for real numbers. And what that's actually saying is that X can be any real number. That's what that means. Okay. Okay, Blaze, you're almost there. What you're describing there is for a hyperbola, and we're gonna get there. All right, the range is always my y values, guys. It's always my y values. So y, for y, if we look at y, I know that y is also going to be an element of real numbers. But if we look at our graph, guys, look at where our graph goes. Can my answer for the y-axis be -3? Yes or no? Tell me in the chat. Can my answer for y be -3? Jasmine?
No.
No, it can't. Why? Because there's no graph here. So how far can my graph actually go?
Because -2 is the asymptote.
Not the asymptote, it's the turning point.
No. The turning point.
There's a difference, and I see why you're saying asymptote.
My teacher taught us that the turning point, beyond the turning point lies the asymptote. So like if we said -2, he'd say that's the asymptote.
Okay, good. All right. We'll accept it as asymptote. But the reason why I don't want to say it's an asymptote, Jasmine, is because we have to include -2. Okay, we have to include -2. So the asymptote we're not allowed to include. So that's why if I say y, it needs to be greater than or equal to 2. But I can see why your teacher would say asymptote. If your teacher teaches it as the asymptote, keep with that, okay? Keep with what your teacher's doing, because she or he's the one who's going to test you, and I don't want you getting the wrong thing over here. Okay, so somebody says, ma'am, please go back up so I can take a screenshot. Where is up? I'm not 100% sure where up is. Teacher Nels, you are DMing me at the moment. You need to switch your chat to everyone.
Yeah.
That's okay. Okay, Askewele, be quick. Be quick. Oh, sorry, it's -2. Sorry, it's -2, guys. Sorry. It's not 2. It's -2. Thank you, Roma, and somebody named User. User, please give us your name. Okay, good. Askewele took a screenshot. All right, excellent. Now, I need us to remember all of this, guys, that the turning point is a 0 for my x value, and wherever where the graph of my y-intercept goes up to, which is -2. That's the turning point. Okay. So let's look at a quick example over here. The example here says, given the graph f of x is equal to 2x squared minus 2. Now it says, determine the turning point. Our turning point, guys, is going to be a point at 0, and whatever this part of my graph is, whatever this part is, this part over here says -2. This is my y value for my turning point. This is my y value. So when I ask you, what is the turning point? The turning point is 0 and -2, my y value. That's my turning point. That's it. Okay, that is my turning point right there. Now, what do I need to do to find my x-intercept again, guys? X-intercept, what do I need to do? Y equals 0. That's it, Funzo. Good. Y equals 0. All right. So we're going to then go into our function over here. Remember, f of x is the same as y, guys. F of x is y. So we're going to replace y with 0. So what I'm going to get here is 0 is equal to 2x squared minus 2. And then we're going to solve for x. Solve for x, guys. So first thing I'm going to do here is I'm going to take out my highest common factor. Yes, Asbonge. Okay, my sweetie, if you're on your phone, like flip left or right, and you'll see a nice big fat speak button, and then you can speak to me. Hi, Asbonge.
Hi, ma'am.
Hi, my sweetie, what's up?
Yes, can I ask that it is wrong if I transpose -2 to the left-hand side and then I divide by 2 both sides and I left with x squared and I introduce the square roots?
No, that is perfect. That is 100% correct. But what is your answer? What did you get? X is equal to?
Let me...
Okay, so we've got, now we've got x
equal to
squared.
1.
Okay, now you've got x squared is equal to 1. But be careful, Asbonge, because if you take the square root of both sides, you must get x is equal to plus or minus 1, positive or negative. Okay, so what you did was perfect. It was 100% correct. Okay, but remember to take positive or negative 1. Okay, well done. It was very nice. Sure. Okay, and here I am trying to show you the long way around, but well done. 100%, my sweetie. Excellent work. Excellent work. All right, so we can do that. I'm actually going to continue over here, and this is dots. So I'm going to do difference of 2 squares over here. Difference of 2 squares. 0 is equal to 2, open 2 brackets for difference of 2 squares. X squared minus 1. I'm going to get x plus 1 and x minus 1. I'm going to divide both sides by 2, divide by 2, divide by 2 to get rid of this 2. 0 divided by 2 is just 0, guys. It's just 0. So I'm going to get 0 is equal to x plus 1, x minus 1. And then I just solve 0 product law. X plus 1 is equal to 0, or x minus 1 is equal to 0. Therefore, x is equal to -1, or x is equal to 1. Right, those are my 2 points. Those are my 2 points of my turning point. Right, so that means that my x values are going to be -1 and 0, and 1 and 0. Those are my 2 x-intercepts. That means if we go back up to this graph over here, in this place over here, I'm going to have -1 and 0, and over here, I'm going to get 1 and 0. Remember, my turning point is at 0 and -2, right there. Yes, Zoluga, you can choose this method, or you can do Asbonge's amazing method. Let me show you guys what Asbonge did. Asbonge did this. She took -2 over to the other side and said 2 is equal to 2x squared, divided both sides by 2, divide by 2, divide by 2. Therefore, she got 1 is equal to x squared, and then she took the square root of both sides, and then she got, therefore, x is equal to, now remember, you're always going to get 2 answers. It must be positive or -1. Okay, so this is one of the ways. You can do this one, or you can do Asbonge's one, that one. You guys can choose which one you're going to do. All right, excellent. Now, when we do our y-intercept, guys, y-intercept, we're going to make x equal 0. So I'm going to go over here and I'm going to say y is equal to 2 multiplied by 0 all squared minus 2. Therefore, y is equal to -2. You will note that our y-intercept is actually our turning point, because the value that I'm going to get over here is 0 and -2, just like my turning point. So in grade 10, my y-intercept is my turning point. Okay, it's my turning point. Now, let's talk about the domain. What do I need to write for my domain of f, guys? My domain? I saw somebody put their hand up and then put their hand down. Remember, my domain, guys, tells me what my x is. X is an element of what? Finish up for me, guys. X is, that's it, Jandre. Excellent, Jandre. Well done. X is an element of any real number. Excellent. Alicia, we know you're brilliant. Wow, love it. Love, love, love it. Awesome stuff. All right. Okay, let's talk about the range. This is the answer for the domain. X is an element of real numbers. Let's talk about the range. Now we're going to go, y is an element of real numbers, but y is what? Finish up for me. Look at my graph, guys. Look at my graph. How far can my graph go? Remember, it can't go any lower than my turning point. So y, we can't just say -2. What goes in the middle here? Mnamani and Funzo, if we say y -2, what goes in here? Is it equal to -2? Is it greater than? Is it less than? What is it? What do we put there? That's it, Nico. Excellent. It's greater than or equal to -2. Okay, greater than or equal to -2. All right, and this is the process that we need to know, guys. We need to know how to find the turning point. We need to know how to find the x-intercept, the y-intercept, the domain of f, and the range of f. You guys are doing amazing. Well done, Sange. All right, I want you guys to look at the next example. This is your turn. Okay, look at this example over here. Now, I want you guys to be very careful. Have a look here. This graph over here is a negative graph. It's a negative graph. So think about whether it's going to be a smiley face or a frowny face, and what that is going to mean for my turning point and for my range of f. Okay, you guys have got 5 minutes to work this one out on your own. Smiley face for a negative. How, Namani? Oh, it's negative, it's depressed. It can't have a smiley face. Yes, it's a sad face. Okay, now think about that, what that means for my range. Okay, 5 minutes, guys. Pop your favorite emoji in the chat when you are done. Oh, Alicia, don't be like that. Hi, Aviani. Aviani, how are you doing, my sweetie?
I'm fine, thanks, and how are you, ma'am?
Excellent, my sweetie. How can I help? Yes, Nico, you need the graph and find me all the stuff. Go for it.
Ma'am, I'm a bit confused when number 5, when it comes to the range.
Okay, so the range is basically our y values. Okay, we are looking for our y values. Now, if you look at this graph up top, okay, up here, right? My y-axis, on my y-axis, do you see how my graph is going upwards? My graph is going up, yes?
Yes.
Okay, so my range is basically saying tell me what y values I can get for my graph. I know, Aviani, that I can't get -3. Do you agree with me? We can't get -3.
Yes, I do.
Yeah, because the graph doesn't come this far down. So my graph is only all these numbers, all these real numbers over here, but it can't be anything less than -2. So the y values must be greater than or equal to the turning point. Okay, so that's why when we write it, y is an element of all the real numbers, but only the real numbers that are greater than or equal to -2. Okay, does that make sense to you?
So if our graph was up to -5, we're going to say y element of real numbers, but y equals to y is greater than or equals to -5.
100%.
Okay. Oh, I understand. And if it was a positive, if our graph was at 2, we're going to say y is greater or equals to 2.
That's it. That's it.
Thank you, ma'am.
You're very welcome, Aswidi. I'm glad you're getting it. 100%. Thanks for that question. That was an excellent question. All right. Let me just scroll down quickly so you guys can have a look at this. 2 more minutes, guys. Remember, pop your favorite emoji in the chat. Notando, do you want to put your hand up and show me how you guys do it at your school to see if anybody else does it that way as well? Hi, Notando.
Hi, ma'am.
Hi, my sweetie. Where do you guys do? What do you guys do differently?
Ma'am, the range.
Okay. How do you guys write the range?
So our range is y's elements of included 0, infinity excluded. So ma'am, when you say it is greater or equal to, it confuses me because now I don't know which the y, is it going to be on the y-axis or x-axis, because we do it like coordinates.
No. They're both correct. They are both 100% correct. Okay. Remember this over here, what I've done over here, and we did this at the beginning of the year. This is called set builder notation. Okay.
Yes, ma'am.
The set builder. What you're doing over here is called interval notation. Okay. It's called interval. If you write this one in an exam, you get your mark. If you write this one in an exam, you get your mark. Okay.
So ma'am, how do you know that it is excluded? Or is it the x value, and then the infinity or negative infinity is the y value?
X value is the domain. Okay.
Yes,
X value here at the domain. So if I had to write the domain in terms of interval notation, I would do this. I would go x is an element of open brackets negative infinity to infinity, excluded on both sides.
Yes,
okay. So that's the domain. The domain only speaks back to the x values. Okay. The range is only the y values. Now remember, because of the turning point, this square bracket that you've given me over here, my sweetie, this square brackets is the same thing as greater than or equal to.
So ma'am, if they give us the set builder notation and then it says greater or equal to, then we know that the 2 or the -2 is going to be first and it's going to be included.
Yes, 100%. So if they did this, my sweetie, if they didn't write that equal to sign, if they just said y is greater than -2, then it's no longer a square bracket, is it? It's going to be a round bracket.
Yes.
Okay.
Yes, ma'am.
So either one of them is 100% correct. Not a single one of them is wrong. I'll show you just now, Notando, when we do this example that everybody's trying, how we can write both of them in either notation. Okay.
Okay. Yes, ma'am. Thank you.
You're very welcome, my sweetie. Okay. So both of them are correct, guys. If you've been taught the interval notation rather than set builder, all of it is correct. Okay. Both of them are correct, guys. Loving the emojis, by the way. Loving the emojis. Everybody's giving fire. I thought Sang is giving me a clown. Mirula normally puts fires out with his ice cube. I'm wondering if we're going to get it. As I said that Mirula is going to put your fire out with his ice cube. And then he puts an ice cube in the chat. Akwando with his food baby. Loving it. Thanks, Blaze. Thanks, Lusanda. Nice one, Snagegele. I like it. Esther with a bombastic side eye. I love it. Hi, Queen Jasmine is now mad at us, is now angry at us. How, guys? Yes. Hope was asking a question saying, does the domain always stay the same? Yes. For the parabola, you will always be able to define it everywhere unless the question says don't. Okay. But for a parabola, we will always get all the x values. Okay. All right. Let's have a look at this one over here, guys. Now, we need to determine our turning point. You guys can pop your answer for the turning point in the chat for me. What did we get for a turning point? Remember, we got this value over here. Abuyani, give me my turning point. Abuyani, are you there?
Ma'am?
Yes.
Our turning point is 0 and 12.
Excellent, beautiful, excellent, good. I need to find my x-intercepts, Abuyani. What would I have to do?
Can I do it, ma'am?
Yes, absolutely, go for it.
Okay, let y be 0. Then
Good, let y equal 0.
0 equals to negative 3x squared plus 12.
Good. Next step.
Then 0 minus 12 equals to negative 3x squared.
0 minus 12. Okay, so I'm not even going to do the 0 minus 12. I'm just going to write negative 12. Is that okay?
Negative 12. Negative 12. Negative 12 equals to negative 3x squared. Then you divide
Good.
both sides. Divide both sides by negative 3.
Good.
Then it will be 4 equals to x squared.
4 is equal to x squared.
Then you square root both sides.
Good.
Therefore, x equals to 2. Therefore, x equals to 2.
2, or remember, we can't just take the 1, Abuyani, we need both. So we need to take plus or minus.
Or minus 2.
Excellent, good. Now you need to give me the x-intercept. I'm going to have negative 2 and
0.
Good. And the other one is?
What?
There's 2 of them. Negative 2 and 0 and 2 and 0.
Oh, 2 and oh.
Okay. Remember, they are.
I get it now. So, ma'am, every time. So each and every time I'm supposed to write plus or minus 2 when I'm finding the x-intercept of the graph.
No, not every time you're finding the x-intercept. When you take the square root of a number, okay, you always get plus or minus that number. Okay, the reason for that, and remember, if I get
okay, I get it. Thank you.
If I get 2 squared is 4, but negative 2 all squared is also 4. Right? Do you agree with me here? Or are you a little bit lost? You're with me. I think there's a bit of a lag.
Oh, yes, ma'am.
All right. Yes. So both of them will give us positive 4. So the square root is plus and minus 4. Yes. Okay, I think she can't hear me very well. Oh my goodness. Oh no, Abiyani, come back. Okay, all right. Let's do the y-intercept, guys. Remember, y-intercept x will equal to 0. Okay. X is equal to 0. So we're going to go over here and we're going to go y is equal to -3 multiplied by 0 squared plus 12. Therefore, y is equal to 12. So again, I'm going to get 0 and 12. Well done, Sange. That's it. We're going to get 0 and 12. What is my domain, guys? What is the domain, guys? Cheers, Tonelo. See you next time. Give me the domain, guys. Good, good. Excellent. That's it, Sange. Well done, Blaze. That's it, Funzo. Excellent. The domain is my x values. X is an element of real numbers. Excellent. Now, let's talk about the range. The range of f, what is the range of f? I want somebody to tell me. I know that I'm going to have a y is an element of real numbers, but now Funzo says y is greater than or equal to 12. But if I draw this graph, guys, if I draw this graph, is it a sad face or a happy face? Sad or happy face? Sad or happy face, guys? Is it? Look at the graph. Look at the graph, Zoluka. Don't just say happy face. It's a sad face, right? It's a sad face. So we can almost look at it as my 12 is over there. There's my turning point at 0 and 12. Okay. There's my turning point at 0 and 12. And again, my graph is going to cut the x-axis at my x-intercept. So this is -2 and 0, and this is 2 and 0, those points over there. Now, if you guys say to me that y is greater than or equal to 12, you're telling me that y needs to be 13, greater than 12. Is there any part of a graph up top? Do I have a graph at 13? No, I don't. No, I don't. I don't have a graph at 13. So I can't say that y needs to be greater than. What do I need to say? Where is my graph actually? Where is my graph? It is less than. That's it, Abiyani. It needs to be less than. So now I need to say that y is less than or equal to 12 because my graph is only defined below 12, not above. Now, for those of you who use interval notation and not set builder, okay, we need to then say y is an element of. This thing is going all the way to -infinity. So we need to start with -infinity, not included, to 12. And then we stop at 12, but 12 is included, so we need square brackets. That's it. Yes, Nyeleti. Positive number equals happy face. Negative number equals sad face. And we spoke about this in last week, Tuesday's lesson. Okay. All right. Give me a thumbs up if this made sense. Did today's lesson on the turning point, x-intercept, y-intercept, domain, and range, does it make sense to you guys? Loving it. Excellent. 100%. Rebetu says kinda. And Rebetu, if you still have questions, don't hesitate to ask, hey? You need to ask. Zoluga, because remember negative numbers. Where do negative numbers go to? What is the last negative number? You can do that, Sike. Yes, you can do that. Good, it goes to infinity, but it's not just infinity. These are negative numbers, Zoluga. So it needs to go to -infinity. But because -infinity is smaller, we must start with a smaller number. We start with -infinity. Okay, -infinity and then the positive numbers. Ooh, excuse me. Okay, Siabonga says, ma'am, I'm still confused on the y-intercept. Remember, for the y-intercept, we just need to make x equal to 0, Sia. Okay. Courtney says, can y be a domain? Absolutely not. Never, never, never. Okay. The domain is always x and the range is always y. Okay, Askewele says, in the turning point, where does the 0 come from? I'm confused. Okay, Askewele, the only reason our turning point 0, the x value for turning point is 0, is because in grade 10, we are only going to move the graph up or down. So it will always be on the x-axis. Your turning point will always be on the y-axis, I mean. So our graph will always have an x value of 0, an x coordinate of 0. Okay, that's why I'm just saying that x is automatically 0. In grade 11, then we start shifting our graph from left to right, and then our turning point is no longer at 0. Okay, but that's a grade 11 problem. Don't make it a grade 10 problem. Okay. So Siabonga, yes, Masudi.
So ma'am, y intercept, is it do we only need to make x 0? Or is there any other step that I need to know?
Nope. You just make any x value. If you see an x in the graph, make it 0. In the function of the graph, make it 0, and then calculate for whatever's left.
Okay, thank you, ma'am.
All right, excellent. Okay, I'm glad we're all together. Let's take a quick deep breath in because we've got quite a lot to get through still. Okay. Okay. In grade 10, you make it 0, Askewele. In grade 11, we'll shift it for you. Okay. Let's talk about the hyperbola. Okay. Let's talk about the hyperbola, guys. I love the hyperbola. It's such a weird graph because technically it's not one graph. It's 2 graphs in one. Okay. It's 2 graphs in one. And that's why I love it so much, because it's such an oddball. It's a weirdo. Very interesting. Now, when we learn of the function of the parabola, guys, this is the original parabola. This is the function of the original parabola. F of x is equal to 1 over x. Now, okay, Namisile, I will go back at the end of the lesson and you can have a look. Okay, and then you can take as many screenshots as you need. All right, now if we look at this, I'm going to ask you guys again, is there any value of x that's going to give us a problem? Can we think of any number that x cannot be? Anybody? If I have f of x is equal to 1 over x, what can x not be equal to? Good. That's it, guys. That's it, Kanyisa. Well done, Namani and Apiwe. 1 over any number will still give us an answer, Apiwe. I'm not Apiwe. So remember, if x is equal to 2, then this answer is just the half. All right. But I know that if I make x equal to 0, if I make x equal to 0, this whole thing is going to become undefined because anything divided by 0 is undefined. So x cannot be equal to 0. X cannot be equal to 0. X cannot be equal to 0. Okay, good. X can't be 0. Now, what this does, guys, it gives me a bit of an issue in that if I'm trying to draw the graph of f of x, this is what I'm going to get. I'm going to get, let's say, for instance, we're drawing a graph, and then I'm going to get to this point, and then my graph is going to be like, whoa, you can't be x. Wherever x is 0, you can't be there. You can't be where x is 0. So my graph can't touch 0. It can't touch 0. Ugh, look at what ma'am is doing now. My graph can't touch 0. So what my graph is going to do is it's going to start doing this. It's going to be like, okay, I can get close to 0, but I can't touch 0. Because this is exactly where x is equal to 0. So it's going to be like, Get as close to 0 as I can. I can be 0,5. I can be 0,1. I can be 0,01. I can be 0,001, but I cannot be equal to 0. I can't be equal to 0. I can get as close as I possibly can to 0, but I can't be 0. I'm going to keep going. I'm just never going to touch 0. Right. But my problem is, exactly. My problem is, I can also put negative numbers in here. I can put -1, -2, -3. So what that means is on this other side of my graph as well, my graph is going to start coming up with all my negative numbers. And then it's going to approach 0. Yo, it mustn't cut 0. It's going to approach 0, and then it's going to be like, oh, I can't touch 0. I can get as close to 0 as I possibly can, but I cannot touch x is equal to 0. So what happens with my hyperbola is I end up with 2 separate graphs, but they are making me, or the function is making me draw 2 different graphs. They are made up of one function. Both of these graphs, this one and this one put together, come from this one function. Both of them are made from that one function. And the reason it cuts the way it does is because my x cannot be equal to 0. Okay, so the graph cuts in 2 because of that x can't be equal to 0. Now, these things are called a certain thing. This x is not be equal to 0 is called an asymptote. X not being equal to 0 is called an asymptote. Asymptote. And I really need to have a conversation with the person who named it an asymptote, because, like, Mr. Metz, you couldn't come up with a better name. Like, why do we need to call it an asymptote? It sounds so, it sounds shifty. I mean, Ivo, Teacher Nelly, did you kick him out? All right, okay. I'm going to let you guys have that conversation. All right, this is called an asymptote. Now, an asymptote is the part of the graph that we cannot touch. Teacher Nelly, you're DMing me again. Okay. All right, so. Oh, sorry. Thank you. Sorry. Because I wrote it wrong, that's why. ASYMPTOTE. Yes, so Funzo, the asymptote is like a fence that we cannot touch. It's a fence that we can't touch. Consequently, guys, in this graph that we have over here, in this graph of f of x is equal to 1 over x, x cannot be 0 and y cannot be equal to 0. Both of them are asymptotes. Okay, both of them are asymptotes. Now, we're going to talk about a razor fence. Yes. Okay. Alusha. Okay, both of them are asymptotes, guys. So it cannot be, x cannot be equal to 0 and y cannot be equal to 0. And this is where the idea of these graphs being like this comes from, the fact that x can't be 0 and y can't be 0. Now, those are the asymptotes. When we talk about quadrants, guys, our Cartesian plane is always, oh, sorry, yes. Notando's like, is this a mother graph? Yes, it's a mother graph. I love that word. Yes, this is the mother graph. Okay. All right. I think Queen Jasmine wants to explain quadrants to us. I feel like she knows what quadrants are. Jasmine?
Yes.
Yes. Are you gonna explain to the class?
Do you want me to?
Yes, absolutely. Takes the pressure off of me. It takes the pressure off of me. Explain quadrants to everybody.
Okay. The Cartesian planes are made out of 4 quadrants, right? 2 being negative and 2 being positive, right? Quadrant 1 is on the right hand side on the top. We have label while I talk.
Quadrant 1. I'm going to use Roman numerals. So quadrant 1.
But fancy there. Opposite to quadrant 1 is quadrant 2.
Good. Quadrant 2.
Below quadrant 2 is quadrant 3, and opposite to quadrant 3 is 4. Quadrant 3 and 4 is the negatives.
Good. All right. Sure. Jasmine, like I said, I feel like one day you're going to take my job, and then what am I going to do? What am I going to do? I feel like one of these days, I'm going to take the night off, and you're just going to teach my class, because I mean, thank you, Jasmine. You're amazing. Well done. Awesome stuff. I feel like I must give everybody a chance. Yes, me. I was about to say everybody. I'm going to give everybody a chance to teach for me, and I'll just get paid. You guys can teach for me, and then I'll just take the money. Alusha. All right. Okay. So, as Jasmine has explained, that these quadrants actually mean something. Okay, they help us to understand the positives and the negatives of things, right? Now, you guys will note over here that this f of x that I've drawn over here is positive. Its f of x is equal to, let me add my positive sign, positive 1 over x. So I know that over here, in this part over here, my x values are positive, and my y values are also positive. So that is why when we draw this particular graph, it's in the first quadrant. This graph is in quadrant 1, right? Quadrant 1. But down here, if I look down here, guys, I know that my x values are negative and my y values are also negative. And I know, guys, a negative and a negative will give us a what? A negative and a negative will give us a good. Not an equals. How can you say? Not an equals, a positive. Good. It will give us a positive. So this graph of positive 1 over x will be in quadrant 1 and quadrant 3. Okay, it'll be in quadrant 1 and quadrant 3. Now, let's talk about if this graph was negative. If this graph was negative, no worries, Kanyisa, it's fine. Right. If this graph was negative, I know that over here, my x values are negative, but my y values are positive. So if the graph is negative, the graph will be drawn in quadrant 2. And also over here, guys, my x values over here will be positive, but my y values will be negative. And a positive and a negative will give us a negative. So my negative graph will be drawn in quadrants 2 and 4. Oh my goodness. Okay, I don't think it's a teacher Nelly thing. I think it might just be something with Zoom. I don't know why you guys are getting kicked out. All right, give me a thumbs up. Give me a thumbs up if we understand the quadrants and the asymptotes, because that's where we're going to pick up in the next lesson, guys. Do we understand quadrants and asymptotes? Thumbs up.